14 days, 2 piston bullies, 4 people. So yeah, 750 kilometers, door to door. Recently, we just got back from Antarctica where we completed about a 2-week ground traverse near the South Pole. We're basically driving piston bullies, tracked vehicles similar to the ones that groom your ski areas. Behind those piston bullies were 60-foot long plastic sled trains, and ultimately those trains carried things like our sleeping tents, fully erected and left standing during the day when we were driving. Kitchen tent, fuel, generators, all sorts of cargo.
But everything we needed for the trip.
And from a both science and survival standpoint. So this entire traverse was in support of ICESat-2, which will launch later in the year.
ICESat-2 is all about measuring elevation, and a natural question is, how do you know you're getting the right answer? This is how we will know. We'll go out and collect a reference data set. We'll be ready to compare and evaluate, see how we're doing.
319 is still kind of ready. How you guys doing over there?
So the big measurement we were making was to measure the elevation of the ice sheet surface around our traverse, and we had the 2 GPS running, one on each vehicle, measuring that elevation. One of the other experiments we were doing is leaving out what we call corner cube reflectors to get an assessment of the pointing of ICESat-2. When we make an elevation measurement, how are we sure it's in the right place? So in this picture, you can see a bamboo pole with a little white cap on the end of it, and embedded in that cap, a little piece of glass about as big as your pinky nail, and calibrated to return green laser light from the satellite. It bounces off of this thing and goes right back up to the satellite again, super reflective. So these things, as Kelly has demonstrated, show up in data with altimeters like ICESat-2. When you first get to South Pole, and you're coming from McMurdo, which is a nice seaside town right at sea level, and South Pole is what, about 10,000 feet. And yeah, you notice it pretty quickly. The temperature is a lot colder than in McMurdo. It's probably 30 degrees, 40 degrees colder, and 10,000 feet higher. Walking from the camp to where we're putting in an array, for example, would be a 10-minute walk, maybe 5 minutes. A couple breaks on the way. It's still pretty high.
The plan is to repeat this traverse for the next 3 years, so 4 years of data total, and that would last the mission lifetime, the mission requirement lifetime for ICESat-2.
ICESat-2 has 1,387 orbits, and so it's cruising around the world, and it's got these unique tracks that repeat every 91 days, and all of those tracks converge right here at 88 South. And so our route crossed, 20% of them? So we can calibrate data from 20% of our tracks with this stretch that we drove, and by repeating it every year about the same time of year, we'll have overlap at exactly the same time, but we'll also be able to figure out what's been going on in between, because we'll measure it in 2017 and then again in 2018, and you can see how it changes from year to year. So that'll be pretty cool too. It'll quickly become the best surveyed piece of either of the ice sheets.